What is up, YouTube? Welcome back to Leetcode SQL 50 series where we solve SQL questions to cement our understanding of the language. Continuing with the series, we'll be solving questions on aggregate functions, which are count, sum, average, min, max, group, concat, functions like that. And when we are using any mathematical or aggregate functions, there are cases where we can encounter nulls or divide by zero errors. To handle that, we'll be using null handling. There are many functions to use like if, null, and so on, but the most common one that is used is coalesce. So that is the background that's required, and let's get started. First question is average selling price. The first table is called prices. Columns are product ID, start date, end date, price. Product ID, start date, end date is the primary key. Combination of columns with unique values for this table. Each row of this table indicates the price of a product ID in the period from start date to end date. For each product, there will be no two overlapping periods. That means there will be no two intersecting periods for the same product ID. Alright, we get the information of prices of products and periods from this table. Next table is called unit sold, which has the columns product ID, purchase date, and units. This table may contain duplicate rows. Each row of this table indicates the date, units, and product ID of each product sold. So for each of the product from the prices table, we'll get the information of the unit sold. Quite straightforward. Let's look at what they want us to solve for. Write a solution to find the average selling price for each product. Average price should be rounded to two decimal places. So we'll use the round function to solve for this, and for calculating the average for each product we need to consider every product's price. So we can visualize it by thinking that when we are joining these tables to find the common ground, we need to consider all the products in consideration. Hence the prices table will be a base table, in other words the table towards the left side of the left join. If a product does not have any sold units, its average selling price is assumed to be zero. This is where we are doing the error handling or null handling. What kind of an error? A divide by zero error, because average by definition is the sum of everything divided by the total number of units. So it is quite possible that there is a product whose price is given in a particular range, but none of the units are sold. So if we divide it by zero, we'll get a divide by zero error. So that must be handled, and we'll be using the coalesce function to do that. Return the result table in any order. Let's look at one of the examples. Here's the prices table. The products 1 and 2 are here with these ranges and corresponding prices. Then the unit sold table, again for product 1 and 2 at a particular time, a particular date in the range, the number of units sold, and finally we are getting the output for each of the product and their average prices. The explanation: average selling price equals total price of product divided by number of products sold. So for product 1, for the first date, that is second, it's 25th of February, which lies in the range of 17th February to 28th February, we're getting 100 number of units sold at the price of 5. And on 1st of March, which lies in the state range, we sold 15 units at the rate of 20 units. So we're multiplying 100 by 5 and 15 by 20, adding them up and dividing it by the total number of units sold for product 1, that is 100 plus 15, 115, and a similar calculation for product 2. So let's get right to writing the query. I'll use my select statement and select both the columns. Left join with prices on left. So the aliases have been given. Let's put the joining conditions. First of all, the common point between these two tables, which is product ID. So p dot product id must be equal to u dot product id, and our next condition will be to identify which particular row of the unit sold table should match with which price to be considered. So for that, I won't be using a direct equals condition in join, rather I can use a between condition, that this date should lie between the ranges over here. So I can write it like this: u dot unit sold between p dot start date and p dot end date. So this will help us identify which purchase date to be considered in our calculations. We'll be getting on to the calculations next after grouping the results. Group by, we need to group it by product id, and the product id should come from the prices table, so I can write it as p dot product id, and I'll do a similar aliasing in the select statement. Now let's calculate our average price. So first of all, let's start with the error handling, the co-lease function. We need to present the value 0 wherever we don't have any units sold, so I'll use a 0 and then I'll put the condition over here. Also, we need to round the result by 2 decimal places, so I'll use the round function by 2 decimal places. And now let's do the calculation. Our calculation is the sum of total units times prices divided by the total number of units. I can use the sum function twice for this. So sum of price at a particular range of time times the units coming from the unit sold table. This sum is done and we're dividing it by the total number of units. So again, I can use the sum function. Alright, looks good to me. Let's give this a go. Yep, the test case is accepted. Let's submit it and check. Alright, we're good to go. Let's move to the next question. This question is called project employees 1. We have the first table called project, where the column is project ID and employee ID. Project ID, employee ID is the primary key of this table. Employee ID is the foreign key to employee table. That's the next table in consideration. Each row of this table indicates that the employee with employee ID is working on project with project ID. Alright, so an assignment of a project to an employee. Next table is called employee with employee ID, the name and experience years. Employee ID is the primary key of this table. It's guaranteed that experience years is not null. Okay, we will always have an integer value over here. Each row of this table contains information about one employee. Alright, let's see what they want as a solution. Write a SQL query that reports the average experience of all employees for each project rounded to 2 digits. Okay, so we want to calculate the average experience. Return the result in any order. Let's see the example and have a look. We have some information of assignment of projects to employees over here and the employee table itself. And this is the output, the project ID and the average years. So as you can see, we are getting the average about each project. We can deduce from here that when we'll be joining both the tables, we need to consider the project table towards the left side of the join, so that all the projects are taken into consideration. Let's see about the calculations. The average experience years for the first project is, okay, so for project ID 1, we have the employees 1, 2 and 3. The employees IDs 1, 2 and 3 have the experience years 3, 2, 1. Sum of 3 plus 2 plus 1 is 6, and divided by these 3 employees, 6 divided by 3 gives us an average of 2, rounded up to 2 decimal places. The next one has 2 employees, employee 1 and 4. which have the experience 3 years and 2 years correspondingly. 3 plus 2 gives 5. 5 divided by 2 gives us 2.5. Alright, let's move towards writing the solution. I'll select the columns first. Again, we need to take the project table towards the left side of the join. Let me give this an alias of P. Then the employees table, an alias of E. The joining condition over here will directly be on the employee ID because that is the common link between the tables. So P dot employee ID equals E dot employee ID. That's the joining condition, and we need to group the results by project ID. I'll also alias it over here. Alright, now let's move to calculation of this average years. Giving this an alias and doing the calculation. I don't think we'll need a coalesce because we have been assured that here the experience years is not nil. So let's start with the rounding function. We need to round our results by 2 decimal places. That's our condition. And over here we can directly use the average function of SQL and solve our question. Quite straightforward to plug and play it over here. E dot experience years is what we want to average out. Alright, looks good to me. Let's give it a try. The test case is accepted. Cool, let's move to the next question. Percentage of users attended a contest. Okay, the first table is called users with user ID and username. User ID is the primary key, column with unique values for this table. Each row of this table contains the name and the ID of a user. Okay, quite simple. Then the register table has contest ID and user ID. User ID is the common link. Contest ID, user ID is the primary key, combination of columns with unique values for this table. Each row of this table contains the ID of a user and the contest they registered into. So the registration information per user and the overall information of users is here. Let's see what they want us as a solution. Write a solution to find the percentage of users registered in each contest rounded to 2 decimal places. Right, return the result table ordered by percentage in descending order. Okay, in case of a tie, order it by contest ID in ascending order. So we'll be using the order by clause over here, and this will take precedence, that is percentage in descending order, and post that we'll also order it by contest ID in an ascending order. That will solve for this. Let's see an example. Here are users, 3 users, 6, 2 and 7, Alice, Bob, Alex. Then the register table with their various registrations according to the contests. Right, lots of rows over here. Then we have our output. We're getting the percentage of registration for each column or for each contest. So this gives us the clue that we need to group our results by contest ID, and hence the register table must be at the left side of the join so that all the contests are taken into consideration. Cool. So let's have a look at few of the results. All the users registered in contest 208, 209, 210. The percentage is 100%. So we have 3 users. So for 208, user ID 6 is present, 2 is present, 6 is present, and 7 is present. Hence 100% registration rate. I think a similar thing for 209 and 210. Then Alice and Alex registered in contest 215. and the percentage is 2 by 3. Okay, so we have a total of 3 users, and Alice and Alex, that is 6 and 2, have participated in the contest 215. We only have 2 rows over here. For 6 and 7 we don't have a row of 2, hence we get 2 divided by 3, that is 66%, 66.67%. Bob registered in contest 207. Okay, so for 207 we only have a single row, no other rows, hence a 33.33%. Alright, cool. So another important thing to note over here is we are multiplying the result by 100. We need to take that into our consideration as well. Let's write the result for this. So selecting the required columns, register table taken towards the left of the join, mind the noise guys, can't really help it. Alright, so first things first, let's complete our join. Our joining condition will be simply on the common link which says user ID. Let's group our results. Just a second, let me clean this up. We need to group our results by contest ID as well, and this contest ID is coming from the register table, so write it as r.contest ID. Let me clean this up over here as well, give it an alias. Now let's calculate the percentage which is required. First of all, we need to round it to 2 decimal places, so giving this an alias, I'll first round. I don't think we'll encounter a divide by 0 error, so police is not required. I'll simply start by rounding it up by 2 decimal places. Now we need to find the number of users that actually are present and multiply it by 100, and then the total number of users should be the denominator for this calculation. So for this I can use the count aggregation function. Count the number of users, user ID is giving us the count, and as I said, we need to multiply this result by 100, and we need to divide it by the total number of users present in the user table. Okay, so to do this, what comes to my mind, which is the simplest approach, is the total count of users from the user table, which in simple words is a select count star from user table, and this can be a subquery. That's why I've put these parentheses. So again, to calculate this percentage, we need to count the number of users which are relevant divided by the total number of users which were present. So doing this division over here, I can have a select count star, that is count the total number of rows from the users table. I think we should be good. Let's give this a go. That will give us the percentage. Okay, let's have a look where we went wrong. Oh, I forgot adding the ordering condition. So let me complete this question by adding that. Silly miss by my end. We need to order percentage by descending order. So percentage DESC and contest ID, that is r.contest ID, by ascending order. That's where it went wrong. Let's try it again. Cool, it's accepted, it's submitted. Awesome. Well done with this question. Moving to the next one. Queries, quality, and percentage. We have a table called queries with query name, result, position, rating. This table may have duplicate rows. This table contains information collected from some queries on a database. The position column has a value from 1 to 500. The rating column has a value from 1 to 5. Query with rating less than 3 is a poor query. A definition in this question for poor queries. We define quality as the average of ratio between query rating and its position. So rating divided by position, the average of this is called something called as quality. We also define poor query percentage as percentage of all queries with rating less than 3. Write the percentage calculation. Let's see what they want us as a solution. Write a solution to find each query name, the quality and poor quality percentage, these two things. Both quality and poor quality percentage should be rounded to 2 decimal places. Return the result table in any order. Alright, we have a single table. We don't need any fancy joins. We just need to do our mathematical calculations correctly to solve for this question. Let's look at the example to understand it better. We have the query name. So 3 rows for dogs, 3 rows for cats. Result has the names corresponding to them. Then the positions and the ratings. I don't think the result column is relevant for any calculation. We'll be needing the position and rating. The output is the query name. So we're grouping the result by the query name. For dog, the quality comes out as 2.5. A ratio between rating and position, and then the average. So ratio between rating and position gives us 5 by 1, then 5 by 1, then 1 by 200 divided by the total number of rows, that is 3, as we can see over here, which gives us 2.5. And the poor query percentage is the percentage of queries less than 3. Simply we can see the ratings. We only have a single row where the rating is less than 3. So 1 divided by 3 gives us 33.33%. And again, this is also multiplied by 100. So we need to take that into consideration while writing our query. So we are only counting things if the rating is less than 3. So somewhere we'll be using the if function. Super noisy. A similar calculation has been done for cats. Let's move to writing the solution. I'd recommend you can mute the video. I'll just be writing it. Picking up the columns. Alright, no joins are required. We just need to group our results by query name so that we get unique values. Query name can be directly fetched. Let's calculate these two. First, let's complete for quality directly. Rounding it up to 2 decimal places. Actually an average over here, not a count. A direct average will help us out. So we need a ratio of rating and position. hope you guys understand why I put backticks, because this was a keyword in SQL. Looks good to me. Let's move to poor quality percentage. Let's do a sum over here. We only need to sum the numerator if the rating is less than 3. So I can use an if condition. If rating is less than 3, then sum up a 1, that is count numbers, otherwise don't count them. So if it is true, we are summing up a 1, otherwise we are not summing it up. That's our if condition. And we multiply this numerator by 100 for a percentage. Then we divide it by the total number of rows. So that can be given to us by the aggregator function count star. Alright, I just messed up the brackets a bit. Actually not over here, after 100. Let's see if brackets look good. Let's try this out. That's the best way to find out. Yep, submitting the code. Alright, the last question of the day. Sorry for the noise, guys. Can't really help it. But I hope that question made sense. You can drop a comment regarding this after watching the video. Okay, last question of the day. Let's finish this off strong. Monthly transactions 1. We have a table called transactions with ID, country, state, amount, and trans date. ID is the primary key of this table. The table has information about incoming transactions. The state column, okay, I earlier thought it was a state of country, but it's a different thing. It's an enum of type approved or declined. Let's see what they want as a solution. Write SQL query to find for each month and country the number of transactions and their total amount. The number of approved transactions and their total amount. Right, we want a lot of things out of this. So, and we can have it ordered by any order. We are not rounding things up, so we should be good. This example is a bit unreadable, so I'll probably drag this out. Yep, this helps. Let's have a look. The transactions table has 4 different IDs. The countries are 3 are US, 1 is DE. Then the states are approved and declined some values, some amounts, and some dates. In the result we're getting the results by month, country, then count of transactions, alright, then approved count, then transaction amount total, then approved total amount. Let's see a few examples. So for the month of December 2018, which is coming from here, for the country US, okay, the country is US over here. So December 2018 considers both of these rows, this the first and the second row for US, and as we can see, the transaction count is coming as 2, as you know both of these dates lie in December. Then we have the approved count, which is coming from a filter on the state. If the state is approved, then we are counting it, hence 1 is approved count. Total transaction amount will be the sum of both of these, that is 3000, and approved total amount will only be this one, so we're getting 1000. Now coming to the month of January 2019, which is these two. We have two different countries, hence US and E both are coming. Each of them has a single transaction count. Both of them are approved, so the approved count is also 1 and 1. The total transaction count is corresponding to each of them. That is 2000 and 2000 populating in these two rows, and since both of them are approved, the approved total count is also the same. Right, quite interesting. So first let me pick up all these columns that I need in my select statement. Alright, month is a keyword, putting it in backticks. Right, we have selected all the columns that we require. Now we have a single table for this question called transactions. No fancy joins required, but some good calculations will be required in this question. And we need to group our results by let's have a look at the question once again. For each month and country. So group by month and country. I think this is fine for grouping our result. Now let's move to the math of it. So I think first of all for month, one important thing to notice, we are not directly getting a month, rather we're getting a transaction date. So we kind of need to extract the year and the month part of it. For that, what I can use is I can either use a substring function, but a very easier use case over here can be the left function of SQL, which starts extracting numbers or characters from the left hand side till a limit. So you want 1 2 3 4 a dash 5 6 7 7 characters. So what I'll do is I'll write left side of this column month up to 7 places. I hope this made sense. And again I'll have to give this an alias of month. So there is that. Hence the first 7 characters of the month are taken and we'll get these values. That's number 1. Country can be directly picked up, no need for a calculation over there. Then count of transactions. Alright, let's do some error handling over here. Just in case anything gets messed up, we don't want it to move, so just giving it a coalesce of 0. We simply need to count the number of IDs in a particular month by a particular month and country, so I can use the count function and count the IDs present inside it. ID is the column. This will give us the count of transaction without any condition. Let me actually first do the count of total amount, because that will also be like directly used over here. So this again, I can give this an alias, start with coalesce. But rather than doing a count over here, what I'll do is I'll do a sum, and what I need to sum is the amount column. We have already grouped our results, so if we sum up our amounts and we give this a coalesce value as well, we can get the total transaction amount. Now let's move towards the conditional counts and conditional sums, that is approved count and approved total amount. It will be very similar to these two, but with an if condition taking place as well. So giving this an alias, putting a coalesce. Coalesce is always a good practice in programming. So I need to count things according to a condition, and we have seen this in the previous question as well. To tackle this, we use the sum and if condition together and we sum up once if the condition is satisfied, otherwise we don't sum it up or we sum a 0 to it. So a sum is used, inside a sum an if is used, and our condition is according to the state. So if state is equal to approved, we want to sum up a 1, otherwise a 0. Alright, another way of understanding this is the opposite way around. If the state is approved, keep adding up a 1, otherwise don't add it up. That's the way to understand the combination of sum and if. Quite a powerful tool to use. And finally, for the approved total amount, a very similar way. Giving this an alias, coalescing it by 0. Again, a sum, and if the condition is same, state equals approved, then only we'll have to sum it up. But this time we don't want to add up ones and count things, rather we want to sum up the amounts. So if this condition is satisfied, we keep summing up the amount. So amount comes from this column, else we don't sum anything up. That will give us the approved total amount. This looks good to me. We've also grouped our results by the required months and country. Let's give this a try. Unknown column, let me have a look what's happening over here. Oh, so alright, the column in the source is not called month, it's actually called trans date. I'll just need to fix this, and the resulting column must be called month. So this should work out. Giving this a shot. Accepted. Let's submit it and see. Alright, so we're done with 5 more questions. Thank you so much for watching, and so sorry for the noise in between, but I'll see you in the next one.